Can anyone hear me? Check, check. Just making sure everything's working. Let's see. Starting my video now. What's up, everyone? Happy Tuesday. Integration B number 3. Who's ready? Oh, man. How was everyone's weekend? I was able to get some hikes in this weekend, which was really nice. The sun was out. We were able to enjoy that for a good minute. And I've been working on a lot of integrals, Feynman technique, lots of other methods that have been driving me crazy. I swear that I feel like I've been dreaming of integrals for the past month, but it's kind of exciting. All right. So I think we're ready. I'm just going to start off like we said like I said, integration B number 3. We've been doing these for the past month, and it's been kind of fun. So, as always, if you catch any mistakes, please let me know in the comments because I am probably going to do some. I will make mistakes. I'm thinking of all kinds of things at the same time. I'm reading the chat. I'm making sure the stream is going well, and I'm making sure that I'm writing everything correctly. So lots of things to keep track of. So if I make any mistakes, please call me out on that. Okay, there's a few that I kind of want to start off with, but let's kind of do, an easy one, I would say, that can kind of, get us warmed up for the day. Okay, this is integral 0 to 1 of e to the x minus 1 dx. What am I writing with? That is a very good question. So I don't know if you can see this on the screen. Hold on. It looks like the lighting's not very good. Let's see. That might be better. Yeah, a little better. Anyway, what am I writing with? It is my iPad. So I am actually on Zoom on my desktop, and I am filming on my phone, and then I have Zoom on my iPad. And this is actually how I meet with every student that I have. We meet over Zoom, and I kind of perfected that. So it works for me. All right, let's go ahead and start with this integral. Does anyone have any suggestions on what we should do? Anything that we can try? These problems, I made some up. I looked for them online. And honestly, I just Google integration B problems. And a lot of these pop up, and I feel like they're kind of fun to work with. So find them online, but a lot of the times I create stuff myself. Okay, so Cal West said, let's go ahead and do U sub. And I think that's probably going to be a good method. So U is equal to e to the x minus 1. And as always, we got to take our du. That's e to the x dx. Ooh, interesting. Okay, so let's see what that's going to lead us to. So let's go ahead and move the e to the x to the other side. I like to divide it so that I have du over e to the x is equal to dx. Okay, now I'm going to go ahead and rewrite my integral here. So I'm going to have integral from 0. Whoops, let's go ahead and do it in yellow. So I have integral of, now I have root u, which was our u value, times, we're going to do du over e to the x. So I have some issues here. One, I didn't write our parameters anymore, okay? Because now this is in terms of u. So let's go ahead and change those. So I'm going to use that u that we have up on top. So when x was equal to 0, because that was the bottom parameter, that means that u is equal to e to the 0 minus 1, which is just 0. And in that top parameter, x is equal to 1, that means that u is going to equal to e to the 1 minus 1, so e minus 1. So let's go ahead and put those parameters up there now. So I have 0, and then I have e minus 1. Yes, definitely need more variables here, that's for sure. Okay, and then I see a u plus 1. Someone said I have to make a u plus 1. Is that going to be on the bottom? For e to the x, I'm assuming that's what I have to do, right? So up on, again, let's go ahead and focus on the u is equal to e to the x minus 1. If I add the 1 to the other side, I get that u plus 1 is equal to e to the x. And what that's going to help us do is that's going to tell us that this u value could go in for the e to the x there, which is really nice. Okay, so now we have integral from 0, e to the minus 1, and then I have root u over u plus 1 du. Oh no, look at that. We still have a pretty ugly integral there, don't you think? Anyone have any suggestions on what we could do here? Because we still have root u over u plus 1, so we definitely have to do something with that. Well, let's go ahead and try a few things. Again, it doesn't look like we can use u substitution. Doesn't look like we can use partial fractions here. So I'm going to focus on that root u. And I'm going to try to change that. Okay, someone say trig identity. It's a possibility. Someone say trig sub. What would I make? What will be my trig sub here? What would I use if that's the case? Nick Bone, and then someone, you don't have a name, unfortunately. Or Nick Boone, maybe? Yeah, it's kind of crazy how we're going to work this out. Anyone have an idea of how we can solve this? We have root u over u plus 1. Okay, so B said u to the 1/2. Let's go ahead and change that first. That way maybe someone could recognize it differently. So this is going to be 0 to the e to the, from 0 to e minus 1, u to the 1/2 over u plus 1. I think that's great, okay? Perhaps if we do that, that's going to help us visualize this differently, or maybe think of a certain method that we could use. Something tells me that you just plugged it into MATLAB, the route Han something. Can't remember. I can't see the name there. But something tells me that you just plugged it into the calculator. Someone said integration by parts. Integration by parts. Okay. So we want to do integration by parts starting from what I have here. Okay, so someone said u sub, u to the 1/2 is going to be our u. I mean, I'm definitely seeing some sort of u sub, or perhaps some sort of u substitution. Yeah, let's go ahead and try u sub again. Yes, this is calculus, by the way. Okay, so it looks like we might have to do u sub again. So u is equal to, well, actually, since we're already using u, let's go ahead and make it w, okay? Nice. So yeah, so I'm going to make it w is equal to u to the 1/2. So dw is equal to 1/2 u to the negative 1/2 du. And let's see if that helps. I would say it is more like AP Calc BC, I would say. Okay, so now that we have our dw, let's go ahead and multiply, or I guess divide by 1/2 u to the negative 1/2, which is really going to be dw, whoops. My iPad's kind of acting up here. Give me a second. Okay, so dw, and then I have 2 root u. dw is equal to du. Well, let's see if that helps us out. Okay, I have to create some space on the blackboard. If you've seen my lives before, you already know that this is what we do numerous times. These problems are not as easy as we want them to be sometimes, so we're always going to have to create some space on the blackboard. Okay, so let's see if we did this right. Now we're going to have, I'm not going to have my parameters right now, but I am going to have w over u plus 1 times du over 2 root u, or dw. Yeah, so what do you guys think? Nothing seems to really cancel out. It kind of looks like we're stuck here. Any ideas? Or should we go back and try to redo it again? Nothing seems to work here, guys. because now I'm going to have an even uglier. Yep, I'm definitely going to redo it. All right. So let's go ahead and start it again. 0 to the 1 of root e to the x minus 1 du. Okay. So let's go ahead and try something else. Okay. Let's go ahead and make u equal to the whole thing, root e to the x minus 1. And let's go ahead and square it. So u squared is equal to e to the x minus 1. And now I'm going to take my derivative. So 2u du is equal to the e to the x dx. If we move the ex to the other side, okay, bear with me. This is going to be 2u. Let me continue writing it in green. So 2u du over e to the x is equal to dx. Okay, now how's that going to look? Or how is that going to look? We have our integral, which I'm not going to put parameters just yet. And then I have root x, which we said was going to be u, times our du was this entire value that we found. So now we have 2u du over e to the x. Let's simplify this. Integral of 2u squared du over e to the x. But then don't forget, e to the x can be found using what I'm about to circle in blue. And now I have u squared plus 1 is equal to the e to the x. And so I can go ahead and substitute that in my integral here. I have integral, let's put the 2 on the outside. I have u squared du over u squared plus 1. In my opinion, this is probably much better, in my opinion. Monkey, I know you said that we almost had it, and I kind of agree, but I think it was going all over the place. So this is nicer, because look at this. Now we have an integral. We're just focused on that integral that we have on the bottom. Don't forget, we have the parameters, which we'll take care of. We'll plug them in at the end. Okay, so let me make this smaller, as we always do. And let's see if we can recognize what we can do with this integral. So we have 2 integral u squared over u squared plus 1 du. What do we think, guys? Should I do partial fractions or should I use long division? Go ahead and let me know in the chat. I can change it to, okay, so almost a partial long division. So here's the thing. Partial could, I think could work. The way you identify whether we're going to use long division is if the degree of the top is equal to or greater than the degree of the bottom. And in this case, it's really nice because as you can see, we have a degree of 2 on the top and a degree of 2 on the bottom. So we're going to divide this. We're going to go ahead and do u squared is on the inside, and then u squared plus 1 is out here. And now we have to ask ourselves, okay, what do I multiply to u squared plus 1 to get u squared? That's just 1. So that's u squared plus 1. And then don't forget, with long division, we have to subtract these. So the u squares cancel out, and we're left with a minus 1. I'll do one with the Feynman technique. Maybe, yes, I do have one here that we can do with the Feynman technique that we actually talked about on Friday, but I'll show you one later on. Okay, so going back to this, now we have 2 integral of 1 minus 1 over u squared plus 1 du. Yo. Uh-huh. Oh, 1 minus 1, yeah. So we could have done part, I guess so. Monkey, I think you're thinking that maybe we could have done partial fractions. And yeah, so look at that. I rewrote this so that this is just 1 minus 1 over u squared plus 1. And now that first integral can easily just become 2u minus, and this second integral is just 2 arctan of u. And then technically, we should put a plus c because we didn't have parameters on here. But I'm going to plug them back in. Okay, so remember that our u was equal to that root x minus, or root e to the x minus 1. Whoops. Okay, here we go. Much better. So let's go ahead and plug that in. So this is 2 root e to the x minus 1 minus 2 arctan of root e to the x minus 1. And then I have our parameters from 0 to 1. So we got to plug in that 1. So we got to plug in the 1 into everything. Whoops, not to that one, into this one. So we have 2 root e minus 1 minus 2 arctan of root e minus 1, which we can't really do anything about it. And then we're going to plug in 0 into both of these terms. And so now we have minus 2. I don't know why it changed colors on me. I was supposed to keep it yellow there. Minus 2. And then this is just going to be square root of 0 minus 2 arctan of, I guess that's going to be 0 as well. So that just simplifies to this. 2 root e minus 1 minus 2 arctan of root e minus 1, and then minus 0. That isn't or that doesn't matter. And then I believe the arctan of 0 is just 0, so that cancels out as well. So this is our answer here. Cosine of ln of x over 1. Oh my goodness, it's so funny that that is there. I'm assuming that I think is going to be a Feynman integral, but I'll write it down if we have time. Okay, so just as a heads up, guys, I will, let me just write this one down so that we can review it. Cosine of ln of x. So just as a heads up, I am going to have to end the stream around like 3:55, but I'm going to come back. If people want me to come back in 2 hours, because I do have to meet with a couple students for some private sessions, then I'll come back after 2 hours. But that's how we do this. This is technically Calc 2, I would say. All right, let's do something that hopefully everyone can kind of digest. Let's go ahead and do, how about we try integral of x to the 5th root 1 plus x cubed dx. All right, go ahead and let me know in the chat what you guys think we should do. What should be the first method? And if you think you know what method it is, go ahead and let me know what that value is. I'm kind of hinting at what that should be. Cosine of ln of x of x. Yeah, that looks like a Feynman one for sure. Okay, so someone said u sub, 100% agree. So let's go ahead and try u sub. Typically, if we're going to do u sub, you know, you want to pick the one that probably looks the most complicated. So in this case, that is u is equal to 1 plus x cubed. So then du is equal to 3x squared dx. Let's go ahead and divide our 3x squared to the other side. So that we are left with this du over 3x squared is equal to dx. All right, let's go ahead and put that back into our integral. Now we have integral of x to the 5th. And then we have our u, which was the 1 plus x cubed. So I'll do u to the power of 1/2. I kind of already anticipate that we're going to have to change this into a 1/2, as we always do with radicals. And then the dx became that du over 3x squared. Okay, so let's go ahead and simplify this a little bit. So now we have, I can pull out a 1/3 on the outside, but then I have x squared times u to the 1/2 du. And that just looks sort of ugly. Okay, Logan Camp said that u sub doesn't work. Well, let's try it. There's a possibility it could work. You'll never know. Okay, so again, every time you're left with like another value of x, go ahead and use our u value to see if this works. Someone said x cubed. Did I not write? Oh, yes, it should be x cubed. You're absolutely right. Thank you for calling me out on that mistake. So someone said it was x cubed. Why? Because when you have x to the 5th divided by x squared, it should be x cubed. I was kind of already thinking what the answer was going to be. So let's go ahead and rewrite that. X cubed. Thank you, BGE. Baguette, Junior, I don't know. Okay, so back to this. Again, u was equal to 1 plus x cubed. Well, look what we can do. We can move the 1 to the other side to get u minus 1 is equal to x cubed. Ah, that's beautiful, because that u minus 1 can substitute in for that x cubed. So now we have 1/3, and then I'm going to have 1 minus 1 to the power of, oh no, this is just 1 minus 1, I'm sorry, because that's x cubed, times u to the 1/2 du. Beautiful. Now check this out. Let's distribute the u to the 1/2, and now we have 1/3 u to the 3/2 minus u to the 1/2 du. Ah. So Logan, what do you think? Was it Logan? Yeah, see? So u sub doesn't work at first, and then you kind of like, mess around with it, and you realize that it does actually work, because now all we have to do is implement the power rule, and it's just going to be 1/3, and then I'm just going to put the 1/3 on the outside first and do u to the, this is going to be 5/2, and then 2/5 on the outside, minus u to the 3/2 with 2/3 on the outside. And obviously we're going to put the plus c. So let's just go ahead and distribute the 3. So we have 2u, well actually I'll do 2u to the 5/2 over 15 minus 2u to the 3/2 over 9 plus c. Yo! And then we can just go ahead and put in the u back in. This is a nice problem. I agree. All these problems, I mean, honestly, I look at these. These are apparently, I believe this one was like an MIT Integration B qualifier. So it's kind of nice to know that we can do these, right? And what makes it difficult is that you have to, like, once you find u substitution that doesn't work, you kind of have to like rewrite it and work out the problems again. Yeah, okay, so I think I am just making sure I'm crossing off the ones that we did already. Let's go to another one. Okay, so how about this one? Someone was bringing this up. I don't know if they're still in the chat, but it was like user 2179. This looks very similar. Check this out, guys. So we're going to do integral of cosine of x, natural log of x, plus sine of x over x. And I guess this is going to be in a parentheses just so we know that we have to integrate everything. All right. Let me know in the chat if you feel like you have an idea what we should do first. Reverse product rule. This was a whole discussion that I've had on previous videos, but that's kind of like it's like u sub, but it's like a shortcut. You should know u sub, and then reverse product rule gives you that. Or perhaps you're thinking about integration by parts. No. I never called it reverse product rule. Yeah, okay. Monkey said split into two different integrals, so let's go ahead and do that. And I kind of agree with this one. Plus integral of sine of x over x. And technically both of them should have a dx there, so I'm just going to write that. Okay, so I separated them. Here's what we're going to do, all right? I'm not even going to touch the first one. Okay, we can definitely start messing around with it, but just from experience, I don't want to touch the first one because I believe someone had mentioned that that the second one is kind of like the first one. Someone had mentioned it somewhere on here, but I'm going to show you what I mean. Okay, not going to touch the first one, but I'm going to go to the first one, or that second integral, and do integration by parts. So my u is sine of x. My du is cosine of x. My dv is 1 over x dx, so the value that's remaining. And then we get that v is equal to natural log of x. So now we're going to go ahead and start rewriting our problem. The first one, again, don't want to touch it. And then that second one's going to be plus, so it's uv, so ln of x, sine of x, minus integral of v du, so this is going to be cosine of x, ln of x dx. Okay, and don't forget that this entire problem was equal to the integral of that top integral that we have there. I don't want to write it because I don't think I have enough space, but I'm just going to call that like I believe sometimes that's how people do it. So this is equal to, I guess I could just say this is equal to I. This is equal to the original integral. Okay, you guys see something that cancels out? Boom, boom. That's the same thing. That's why I said let's not even integrate that first one. So now we're just left with natural log of x, sine of x was equal to I, and I was the integral. Yeah, this was kind of annoying, but I remember when I worked this one out today, I was integrating the first one and I couldn't work it out, obviously, because it just doesn't work. Um, I wonder if you can do a Feynman technique. I'll try to do a Feynman technique at the end. Again, someone had recommended a problem. I don't know if that's how you solve it, but we're going to try Feynman technique after that. Yeah, it's sometimes nice to just notice the product rule in reverse 100%. So honestly, integrals, the thing about it is that it's not as elementary as derivatives. Derivatives, you just kind of know the rules and you just do it every single time. With integrals, you really have to recognize some patterns, and it's all about little tricks. I like to think of them as fun puzzles. So I really devote a lot of my time just doing these because they're just so damn fun. Okay, what should we try next? Let's do, how about integral of 1 plus sine of x on the bottom. Sorry, dx over 1 plus sine of x. Yeah, integration by parts can get confusing for sure. Oh, yeah, multiply by the conjugate. You might think, so again, this is all about identifying tricks. Is this inverse tan? I don't know. Let's try it out. Perhaps it could possibly be, but someone suggested go ahead and multiply both the top and the bottom by the conjugate, and that's exactly what we're going to do. And then so now we have 1 minus sine of x dx on the top over, and then if you on the bottom, if you use the FOIL method or distributive property, we're just going to get 1 minus sine squared of x. Yes, calc is actually pretty enjoyable. I agree. Just got to work with it. And it's kind of cool that, like, man, I know every area of math before calculus. You're talking about, geometry, algebra 2, algebra, and if you succeed at that, calc you can say it could be a walk in the park. So be careful with that. Nick Bone, you said 1 minus 2 sine x, sine 2x. And I think you meant like sine squared x. But just be careful with that, okay? Because when we FOIL that, the signs cancel out. But and then there you go. You redeem yourself. Cosine, this bottom value is going to be cosine squared x. This is just a Pythagorean identity. So now we have 1 minus sine x over cosine squared x dx. Okay. Now at the bottom, we only have a single term on the bottom. What should we do? Let's go ahead and split these bad boys up. So every time we only have one denominator, we're going to split them up. So that's 1, and then it's just sine of x over cosine squared of x. Okay, that first one, let's rewrite that as integral of secant squared x. I'm sure we can recognize that pretty well. Minus integral of sine of x over cosine squared x. Easy. Yep. Left integral is tangent. That's just the derivative of tangent. So we know that's going to be tangent of x. And then we're going to go ahead and take the bottom in order to implement this. Tan x cosine x. Tan x. Oh, tan x over cosine x. I think. I don't think there ever was a dy. If you see a dy, that was definitely just my bad writing. It's all been a dx. I think, yeah, I'll try better to write stuff down. Yeah, so let's be careful with this one because a lot of people seem to have different answers. Second integral is tan x secant x. Let's try that, and I believe that will be correct. Well, on the bottom, we have cosine squared x, so we have to let u equal to cosine x. Du is equal to negative sine x dx. If we divide the negative sine x to the other side, this is du over negative sine of x is equal to dx. Okay, so as we're writing this integral, this is integral of sine of x over u squared, and then du over negative sine of x. As you can see, the signs cancel out. I could bring this negative on the outside. And what do you know? I have to create some space on the blackboard. And guys, someone asked me, what program do I use? I am on Zoom right now. I am on Zoom on my desktop. And then I am on Zoom on my iPad that I'm writing on. And this screen is just like a background that I created. And then I'm just writing on it. So let's see. Just so everyone looks, I have tan of x minus, or now it's going to be a plus since I brought the negative on the outside. And I have integral of 1 over u squared du. And that just becomes negative 1 over u plus c. And then my c is going to go back. Tan of x minus 1 over cosine plus c. That's my integral. So Logan was bringing up this idea that this value, sine x over cosine squared x, is just the same thing as tan of x over cosine of x, aka tan of x secant x. Oh, shit. That's what everyone was telling me. That's so funny. Yeah, so you're saying that this is just the integral. This integral is just secant, which that's what we got. That's so funny. I complicated that so much. My bad. But here's the thing, right? A lot of the times, and I get this on videos, like, you could have just done this, yeah, but sometimes people don't visualize that. And when I was reading the chat, I think it was Logan that was saying it. I didn't understand what was going on, but now I get it. Yeah, so they're just saying that instead of doing u substitution, we just say this is equal to tan x secant x, which is just secant of x. Thank you, Logan. Shout out. All right, guys, let's go to another one. This one was actually requested by someone on my Instagram. I made a post on my stories, and they had requested that I do this one specifically. But let me just erase the one that we just did, so we don't have to worry too much about it. Okay, it is this one. Integral of 3 over 6, or x to the power of 6/5. I'm sorry. And then we have sine of x squared plus x cubic root of x squared all over x squared. But hold up, I actually want to make sure I wrote this one correctly, because I have a feeling I missed something there. So let me just double check. Let me just double check. It looks like, no, everything was correct there. Okay, wrote that correct. Any graphing calculator recommendations? I personally like the TI-84. I really like it, and I have like built-in programs that people download on my website that can do like LRAM, RRAM, distance formula. It's a nice thing that you can use for your SAT and also just to reference it. It's not necessarily, you know, something that you can use as a cheat code, but I think it's just a nice shortcut. But TI-84, highly recommend. I might. Monkey said I might run out of space. Who knows? All right. Here's the thing. With a problem like this, I personally like these, and I've written these before in some of my my books. I always suggest, if you have something this complicated, it's only meant for you to do this because you should definitely try to rewrite this ugly part that we have inside. Some people might find it beautiful, but it's kind of, in my opinion, it's ugly. Whatever. So I have x squared plus, let's just rewrite this, x times, and let's rewrite that radical. This is going to be x to the 2/3. Okay. So before I even do anything else, let me go ahead and rewrite this. This is x squared plus, when I multiply those two x's together, the x times x to the 2/3, I am going to get x to the 5/3 all over x squared. Someone said we can factor out an x. Let me simplify this and let's see, because I think you're right. We might have to factor something out. On the inside the sign, we have one denominator for both terms, so I'm just going to separate it. So this is going to be 1 plus, and then now this is going to be x to the 5/3 minus 2. Let's rewrite this. And so that's just going to be 1 plus x to the negative 1/3, I believe. Was that correct? Nice. Inside becomes 1 plus x to the negative 1/3. So again, it might look confusing at first, but it's all about just simplifying things as much as you can. All right. So now it looks like we can start our u substitution. So u is equal to 1 plus x to the negative 1/3. Obviously, we want to get rid of those things inside the sign. Our du is negative 1/3 x to the negative 4/3. Yep. Dx. And then let's multiply negative 3 to both sides so that I have negative 3, and then x to the 4/3 du is equal to dx. One of the things about calc is that, the methods are one thing, but if you don't know your algebra, like adding and combining rational exponents, you're going to have a big issue. Okay. Yeah, integration by parts might come. We'll see. But let's go ahead and rewrite what we have. So we have 3 over x to the 6/5 sine of u times negative 3 x to the 4/3 du. Okay, so now, as Monkey had said, you are going to run out of space, and they were correct. All right. Yo, does anyone know how I can get a freaking a token key to go live? I want to go live on OBS, and gosh, it will be so cool because then we can have like lo-fi music in the background. I can switch screens back and forth. The quality will be much better. If anyone knows, let me know. Get back to this. Multiply the 3 and the negative 3. So now we have negative 9 on the outside. And then we have sine of u times x to the 4/3 over x to the 6/5 dx. Fuzzy balls, good luck on that Calc B test. All right, let's go ahead and combine this. So we need to combine the x on top and the x on the bottom. And how are we going to do that? We are going to subtract the exponent. So this is x to the 4/3 minus 6/5. I'm definitely just going to show my work here. This is 20 minus 18 over 15. X to the 2/5 is my answer. Okay, I subtracted the exponents. And now I have negative 9 integral of x to the 2/5 sine of u dx. Bruh. Someone said x to the negative 4/3. Yay. So here's why it wasn't negative anymore. So let's look at this step right here. I'm coloring that in, or I'm circling that in green. So if you look at this, this is du negative 1/3. And then because it's x to the negative 4/3, it's going to be x to the 4/3 on the bottom. And yes, thank you, Kay. I will change that 2/5 in a second. And then so what we did is we multiplied both the top and the bottom by 3x to the 4/3, or negative 3x to the 4/3 on the other side. And that's how it became positive 4/3. Okay, because it was originally on the bottom when we took the derivative because of that negative exponent, but then when we multiplied it to the other side, it stayed on top. Okay, so going back to this problem, it was 2 over 15 for our exponent. Thank you very much, K. So now that we changed that, so this should have been x to the 2/15 when we subtracted these. I think we did that correctly. 4/3 minus 6/5. That's going to be 20 minus 18. Yeah, that's correct. Okay, so we have x to the 2/5. No way. Okay, how do we change this? Well, we still have x, so we're going to use our u value that we originally had. Let's color this in red, or let's write this in red. U is equal to 1 plus x to the negative 1/3. Let's bring the negative 1 on the other side. So now we have x to the negative 1/3. Bruh, we need to make this somehow 2/5 or 2/15. No way. Ain't no way. I'm telling you, I think I rewrote this problem wrong, and there's a typo on there. Something should have been like an x cubed or something like that, because that would have made things a lot easier. Unless you guys see something that I didn't write correctly, but I almost guarantee that I wrote this wrong to begin with, and I can't see the correct one. Because somehow this tells me that, yes, it was going to be an integration by parts problem. Because if I try to make this in the 2/15, shoot, I'm going to have to square it. square both sides, and then I'm going to have to use, take it to the 5th power. Bro, that ain't going to work. No way. Yeah, so something tells me there was a typo there. But the point of, or the whole point of this is to make sure that we simplify the inside when it looks this complicated. Okay? Yeah. I agree that integration of parts, Arthur, was going to be the correct one. But again, I think I had a typo on this when I wrote it. So I definitely have to revisit that and see what I wrote instead. Because something tells me that on the outside, maybe it was something else. It wasn't going to be like a 6/5 or something like that. All right, so let's go ahead and do another problem here. Let's do this one. This is one of my, I don't know why I like this one so much. So I have 6 over x to the 29 plus x dx. All good. This is all about just having fun. Integration problems are like puzzles. Again, if you're in trig right now, you'll see this next year. Not this complicated, but you will see it. All right, so this is x to the 29. Let me make it bigger so that you guys can see it on the screen. 6 over x to the 29 plus x. Does anyone have an idea of what we can do here? Let's go ahead and try and factor out the x. Yes, Brady, I completely agree. Let's factor out an x, because now we have x times x to the 28 plus 1 dx. Okay. Now, here's the cool part. Technically, partial fractions will work, but look at that bottom value. Okay? We have x as 1, so technically if we rewrite this as partial fractions, it'll be like a over x plus, but look at that second part. If we write x to the 28 or 28 plus 1 on that side, we are going to have a bad time. Okay? We're going to have a bad time. Because then on the top, we have to do like bx to the 27 plus cx to the 26 and so on and so on. So we're going to have all these values on top. So partial fractions, this is why they try to trick you on this one, because partial fractions will give you, it will be a huge pain. Okay, so Monkey said factor out the 6. That's what I'm going to do. And look what I'm going to do with that 28. I'm going to rewrite it as x to the 14 squared plus 1. You're going to see why I'm doing that. I just rewrote it. The reason being is because, you know what? I'm so used to seeing problems like this, so maybe, just maybe, it's going to be like an inverse trig. Yeah, so people are kind of seeing that it could possibly be that. So let's go ahead and work that out. So u is going to equal to x to the 14. du is equal to 14x to the 13 dx. And then again, divide the 14x cubed to the other side. And then we're left with du over 14x cubed is equal to dx. Okay, so now we're going to go ahead and write that into our problem. Yeah, it was, I don't know what channel you're talking about. I did a few problems like this. I'm still trying to solve. I'll tell you what problem that I cannot solve, and I'm not even going to try it today. But I'll show you at the end of this. So we have dx over x, and then we have u squared, because remember, our u was x to the 14, so we're going to square it, plus 1 times, whoops, I'm not going to put dx there just yet, because our dx is du over 14x cubed. Okay, a couple things that I'm going to do. The 14 is going to go on the outside as a denominator. Derek, this is technically, I would say, BC. But you can do this in AB. I mean, I've seen people do these problems in AB. It's all about just, again, having fun with this. We're just learning different methods. Okay, I brought the 14 to the other side. And now this x cubed, my voice just cracked there, is going to multiply to the x. So now we have 6 over 14 integral of du over x to the 14. Because when you multiply the x and the x cubed, that's what you get, u squared plus 1. Yo, we recognize that x to the 14. It's that u. So now we have 6 to the 14 integral of du over u times u squared plus 1. Ah. Okay. Can we do arc length? You know what? That could probably be today's integration on Thursday. I can probably I can do some arc length. I'm gonna do some volume. I'll do a lot of AP review stuff there. Let me go ahead and make some space in the blackboard. And Monkey, I saw that 14x cube that you were talking about. Fract out of 6. Okay, never mind. Okay, so let me make this smaller. And then now, I believe it was Brady that had mentioned this. We are going to do partial fractions. You're going to see, because now we have 6 over 14 integral of du over u times u squared plus 1. And that is, in fact, a partial fraction decomposition problem. So a over u plus bu plus c over u squared plus 1. Don't worry. Trust me. If you're in AB right now, just continue going through that process. This is all about good fun today. Integration Bs on Tuesdays are just to have fun on some types of integrals. Learn techniques, okay? In my opinion, when I love watching YouTube videos of people solving integrals, because to me, it makes me learn about different methods that I wasn't aware of. So this is all just about having fun. On Thursdays, I'll do more calculus, like A, B, and BC stuff. Like I can probably do arc length and volume. And then Friday, I can do some off-trail math. So we can get crazy with some methods or just do specific things that you guys want to do. It's okay. It's okay if you're lost. Okay, Airborne, the reason I use BU plus C was because look at our variable. I can't make it, first of all, on the bottom of that BU plus C, we have a U squared, so it's a quadratic. So the top, the numerator has to be, our numerator has to be a linear function. Oh, and I see what Monkey was saying, 14x to the 13th, yeah. So they were referring to this one. Let me highlight it in green. They're referring to this problem over here. That should have been a 13. You're absolutely right. I'm going to change that. And then this section here should have been a 13. So when you multiply it, you get the x to the 14th. So I had the right idea. I was already thinking of the 13th, but yes, I'm just rewriting it so people can look at this. Okay, so now, as we're doing partial fractions, a times u squared plus 1 plus b, let's put a u there. U, b, u plus c is equal to, technically there's a 1 because the numerator is a 1. Okay, so this is a u squared plus a. All I did was distribute the a. Plus, my iPad's kind of being dumb right now. Okay, here we go. Plus bu squared plus cu is equal to 1. And if I combine the u squareds, that's a plus b u squared plus cu plus a is equal to 1. Yes, Organic Chemistry Tutor is legit. You go cover or review some of his videos for basic stuff. Honestly, Google things and just look up different methods. Everyone teaches it differently, so whatever you guys feel what works for you, the more you see it, the better it gets. Okay, so looking at this, we need to match the left side of our values to the right side. So that means that a is going to equal to 1 because that has to be our constant. There's no x value or u value on the right side, so c has to equal to 0. And so that tells me that the a plus b has to equal to 0, but a is already equal to 1. So that means that b is going to equal to negative 1. And so that's going to give us this really nice integral. Let me go ahead and write that out for us. Yo, we make this smaller and smaller and smaller. If you guys were here last Friday, it got crazy with the Feynman technique. It was insane. We'll do a Feynman technique after this, and then we can see how long that takes us. All right. So we have 6 over 14, and then now we have the integral. We have the partial fraction decomposition. So now we have 1 over u plus negative u over u squared plus 1 du. The first one is just going to be a natural log. And then that second one is technically, whoops, it should be a minus 1/2 ln of u squared plus 1. And the way I solved that was use substitution. Okay? And then we have plus c. And don't forget that our u was x to the 14th power. So this is 6 over 14 natural log of x to the 14th power minus 1/2 ln of x to the 14th power squared plus 1 and then plus c. And we are done, guys. Nice. Really, really nice. Okay. Do you guys want to do a long division problem, or do you want to do a u substitution / integration by parts problem? What do you guys think? Let me know. Long division or integration by parts / u substitution. Okay, so someone said parts. Okay, parts. I'm seeing parts and long division. You know what? I think we got time for both. Okay, so it looks like parts is the most popular one. We'll do that first, and then we can do the other one, which is going to be the long division, and then we can call it. I think it was Brady that I was talking to. I'm still trying to solve this integral. We're not going to solve this one. This is not the integration by parts one. I'm just letting you know this is the integral that I've been trying to solve, and it is driving me crazy. Okay, I know there's a specific way of doing this, but I'm trying to do the whole partial fractions, and it's driving me insane. I think it's kind of fun. So work it out. Try to do that one on your own, and you'll see that it's quite difficult. Okay, so I have x times arc sine, or sine inverse if you want to see it that way, over 1 minus x squared dx. Okay. Did I think this was going to be integration by parts? I guess so. All right, so what do we do with this problem? Any suggestions? Oh, people keep saying u sub integration by parts. The answer is 2. Okay, so okay, a lot of people are saying u sub. Yes, so our u is going to be let me write it as, I'm just going to do sine inverse, but it's arc sine. And then du is equal to 1 over root 1 minus x squared dx. Fits nicely. I think a lot of people were trying to see that. Let's multiply the root to the other side. So we have 1 minus, or root 1 minus x squared du is equal to dx. Okay, and it looks like now we can go ahead and plug that into our integral. So we have x times u over root 1 minus x squared times root 1 minus x squared du. And I like to write this because some people are, might get confused where, things cancel out. But this value here was our dx, just as a heads up. Okay, so now the roots cancel out, which is really nice. But then we're left with x times u, du. How do we find that x? Andrew, this is calc. How do we find our x? There we go. So Monkey was saying that x is equal to sine u. Now, why is that? Let me circle that in red, because our u was equal to this arc sine. So if we take the sine of both sides, sine of u is just equal to x. So we're just going to go ahead and write that. So now we have sine of u. Actually, let me put the u out in the front. U times sine of u du. Yo. And I think from here, I feel like everyone knows how to solve this. Integration by parts, baby. U is equal to u, or let's do w. So then dw is equal to du. dv is equal to sine of u du. And then v is equal to negative cosine of u. And so now we have negative u cosine of u plus integral of cosine of u du. And now we get our answer. Negative u cosine of u plus sine of u plus c. If I made a mistake on those integrals, because I always confuse sines and cosines, but I think that's going to be correct. And then don't forget that our u was that arc sine, so we just have to plug it back in. Let me go ahead and do that, and then we can do a long division problem. Yo. And I did not forget someone that had suggested that Feynman integral. Well, I'll try to do that, or I'll make a video on that maybe tonight. Chat GPT. No, man. Crazy. Okay, so negative sine inverse of x cosine sine inverse of x plus sine of sine inverse of x plus c, which technically that sine of sine inverse of x can be just x, but we'll leave it as sine of sine inverse. And that is our integral. All right, see you, Brady. I'll see you on Thursday or Friday, or I'll see you next Tuesday. Take it easy. All right, guys. Last one for the day. We're going to do some long division. X to the fourth plus 4x cubed plus 6x squared plus 4x plus 1 all over x to the third minus 3x squared plus 3x minus 1. Sequences and series, they can be a little tricky. Annoying, but tricky. All right, so let's go ahead and do some long division. As you can see, the degree of the top is greater than the bottom. So let's just go ahead and set that bad boy up and see where that leads us. Plus 6x squared. And does anyone recognize that denominator? I'm only saying it because I think we're going to have to rewrite it at some point. All right, let's go ahead and find the values. Let's see, I think I need to multiply this by an x so that I get x to the fourth minus 3x cubed plus 3x squared minus x. And then don't forget that whenever we're doing long division, we have to subtract everything. So the x to the fourths cancel out. This becomes 7x cubed plus 3x squared plus 5x plus 1. And let's see, we introduce a plus 7. Nice. Yes, math nerd, that's going to simplify to x minus 3 cubed, and I think we're going to use it. Okay, so now we have, when we multiply the 7 into everything, we get 7x cubed minus 21x squared plus 21x minus 7. And we're going to subtract all this. So the x cubes canceled out, and then we have 24x squared minus 16x plus 8. And here is our new integral, as easy as we can make it. X plus 7 plus 24x squared minus 16x plus 8 all over our denominator. Not bad, huh? Okay, those first two terms, the x and the 7, that's just power rule. We're just going to integrate that using power rule. So let me just rewrite that now. So now I have x squared over 2 plus 7x plus, and then I still have this integral. Yeah, Stella, see you soon. Did not forget. Everyone say hi to Stella. All right, guys, on the bottom, let's go ahead and simplify this. I think Math Nerd had said x minus 3 cubed, so we're going to go ahead and rewrite that now. All right, who can tell me in the chat how we're going to simplify this? Arthur, I just saw your comment too. I might have missed a negative. We'll look back at it. I'm going to post this on YouTube as well, so we can definitely review that. I'll check it myself, but thank you. Yep, partial fraction decomposition. Yo, this is going to be so annoying because this is going to be a over x minus 1 plus b over x minus 1 squared plus c over x minus 1 cubed. You have to account for every single value. Can I factor out the numerator? Connor, let's see. I didn't even think about that. Maybe I'm just trying to be lazy. Let's try to factor out the numerator. So he's saying that we can definitely cancel out x minus 1. Let's try that before we continue. So on the top, we're just going to factor this. Let's see. Let's go ahead and factor out an 8 from everything so that we get 3x squared minus 2x plus 1. Yo. Okay, so 3, -2, -3, and 1. Oh, so the top. Wait, before we do anything, guys, shout out to Connor. Connor's like, wait a minute. Why are we trying to make this harder? Look what Connor said. On the top, that's just going to be 8. And then that cancels out, or that factors out to 3x plus 1 times x minus 1 over x minus 1 cubed. Yo, and then the x minus 1s cancel out. Nice, because look at this. Now we have x squared over 2 plus 7x plus integral of 8, 3x plus 1 all over x minus 1 squared dx. 3x times negative, two numbers that multiply to 3 and add to -3. Oh, yeah, see, that doesn't, I was just trusting, wait, so then this doesn't factor out. Yeah, I was already thinking, yep, Thank you, math nerd. Guys, this is amazing. So I followed my instinct. Connor, I think you were on the right track. We looked at it, and I trusted that it worked. And then math nerd's like, wait, that doesn't factor out. And he's absolutely correct. That does not factor out to that. So we got to go back to the drawing board, and we have to just use partial fraction decomposition using those values I mentioned. So this is going to be our value, unfortunately. X squared over 2 plus 7x plus, and then now we have a over x minus 1 plus b over x minus 1 squared plus c over x minus 1 cubed. Unfortunately. Dang. Okay. Well, let's go ahead and fix this. For that first one, for the a, all we have to do is a times x minus 1 squared plus b times x minus 1, and then just plus c. And that's equal to 24x squared minus 16x plus 8. And I don't feel like distributing any of this stuff, so we're just going to plug in values, okay? And this is what I mean by plugging in values. On the left side, let me, if I make this smaller, on the left side, I can make x equal to 1. And that will mean that a times 1 minus 1 squared plus b times 1 minus 1 plus c is equal to 24 times 1 squared minus 16 times 1 plus 8. On the left side, the a's and the b's cancel out, so that we have c equals 24 minus 16 is going to be 8 plus 8. That's going to be 16. Okay, and now we can go ahead and plug in some other values. Now that we know that c is equal to 16, let's go ahead and plug in, we're going to have to like plug in something like, let's do -1. So then a times -1 minus 1 squared plus b times -1 minus 1 plus 16 is equal to 24 times -1 squared minus 16 times -1 plus 8. This is what you have to be very careful with your with the values that you plug in. So on the left side, the first one, -1 times, or -1 minus 1 is -2. Square that. That's going to be 4a plus, I guess we can do minus 2b, because -1 minus 1 is -2, plus 16 is equal to 24 plus 16 plus 8. So this is going to be 4a minus 2b plus 16 equals 24 plus 16 is 40 plus 8 is 48. So if I subtract the 16 to the other side, I get 32. So 4a minus 2b is equal to 32. So now we need another value that relates a and b. So we need to plug in one more term, and then I swear we're almost done with our partial fractions here, guys. What should we plug in? Let's go ahead and do x is equal to 2. You don't want to put anything big because then you're going to have to actually calculate that as well. So a times 2 minus 1 squared plus b times 2 minus 1 plus 16 is equal to 24 times 2 squared minus 16 times 2 plus 8. Okay, so let's simplify this. 2 minus 1 squared is just a plus b equal, or plus 16 equals, shoot, 24, bro. Got to be very careful here, guys. 24, I'm just going to do this on my calculator. 24 times 4 minus 32 plus 8, and I get is equal to 72. So then A plus B is equal to 56. Okay, so now we have 4A minus 2B is equal to 32. A plus B is equal to 56. Let's go ahead and multiply the bottom equation times, let's cancel out the B's. So that we get, let's multiply the bottom by negative 2. So that we get 4A minus 2B is equal to 32. Negative 2A minus 2B, or plus 2B. I should just multiply by a positive 2. So let's do positive 2A plus 2B is equal to 112. And then so 6A is equal to 144. So that makes A equal to 24. Nice. Almost done, guys. So now that A was equal to 24, don't forget that we can use the fact that A plus B equals 56. So 24 plus B equals 56. So B is equal to 32. Okay, I know it looks messy, but we're about to finish. So let's just go ahead and set up the partial fractions that we had. And then we can move forward with our integral here. So then this is what we have. We have x squared over 2 plus 7x, remember those, plus integral of the a value, so 24 over x minus 1, plus b, which is 32 over x minus 1 squared, plus the c, which was 16 over x minus 1 cubed. And all these values, all these integrals can be solved using u substitution. So we are left with x squared over 2 plus 7x plus 24 natural log of x minus 1 minus 32 over x minus 1. I just used the power rule there. I kind of just skipped some parts there. And this will be minus 8 over x minus 1 squared. And then plus c. Guys, chat, we have officially integrated that long division problem. This was an MIT Integration B qualifier question, so it's kind of nice that we can do it. It takes some time, but it's totally doable. Yeah, as you can see, the long division problems definitely take some time. This is technically, I would say, Calc 2, maybe some Calc 1, integration by parts. Yeah. All right, guys, so that kind of does it for today. I do have 2 more students that I have to meet. I am going to probably, maybe I'll come back later tonight. I can maybe stream for like another hour or 2, but hopefully maybe I'll do some like volume, or I'll see if that happens. I'll see how my schedule looks like. But in the meantime, feel free to, follow me on Instagram, here on TikTok, subscribe to my YouTube channel, and I'll see you guys on Thursday. If I don't see you guys later today, I am going to do some volume areas underneath the curve. I'm going to do volumes of cross sections. I'm going to do probably some arc length. And then if I have time, we'll do like the Feynman integral technique that we've been talking about. All right, guys. I hope you guys have an amazing Tuesday or rest of your Tuesday. I will see you guys real soon. If it's not later tonight, I will see you guys sometime on Thursday. Okay? All right, everyone. Take it easy. Ta-ta.